exponential function is written this way. Y equals, so far nothing's changed, a times b to the x. Okay. So one of the things that's tricky about this is that when we did y equals mx plus b, b was the y-intercept. That's not the case this time. But I will tell you that there is a y-intercept in the problem. Instead of b, it is a. So whatever that number is in front, a is what we call the y-intercept, or this becomes important later on. It is the initial value. What does initial value mean to you? Where, yeah, like the starting value, where you would start at. Okay, and so that becomes important later on because I'll often tell you where it starts and then you know what a is. All right, here's the deal with b. Do you see how it's raised to the x? That's going to be what's being multiplied. So we're going to have to figure out, okay, what are these numbers being multiplied by? So b is the multiplier. Okay, so this is kind of common sense. What would happen if you multiplied by 1 over and over and over? It would stay the same. So you're never going to see an exponential function where b is 1. What if something was bigger than 1? What would happen if you started, let's say I multiplied by 3 over and over and over? What would happen to those values? Would they go up or would they go down? They would go up. So when b is greater than 1, when you're multiplying by numbers greater than 1, what you're going to see, I'm going to just draw what the curve looks like. So would you start your curve slightly above the x-axis over here and make it curve up like that? And by the way, the curve will never go below the x-axis. Because a negative exponent doesn't mean to make it negative, it means to flip it. So you're going to get really, 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 really small numbers, but they're going to be positive, okay? So what would happen, by the way, do you think this is growing or decaying then? Growth. This is a picture of growth. What would happen if you multiplied by like, okay, a number between 0 and 1? So what if I multiplied by 0.25 over and over and over? It would get smaller and smaller. Now, it would never be negative, but it would get closer and closer and closer to 0. And so that, the curve goes down like this, which makes sure it still doesn't go below the x-axis. And instead of growth, we call this decay. So those are the two types. Okay. So a couple things. First of all, what if I have a bunch of numbers and I'm asking you what kinds they are? Are they lines or are they exponential data? I'm going to just tell you, if they are linear, remember that phrase, linear? When you subtract the values, they'd have the same, right? Because the slope means a same rise over run. Exponential, when you divide them, they'd have the same ratio because they're multiplied by the same value. So how can we tell if the data is exponential or not? We would take as x values increase by 1, we would take the y values have the same multiplier. As x values increase by 1, y values have the same multiplier. Okay. So, now, where is this coming from? What is an asymptote? What is that word? Asymptote. It's kind of weird to say. Asymptote. The asymptote is a line that a graph approaches but never touches. A line that a graph approaches but never touches. We do not spend much time in algebra talking about those, except just to point them out when they happen. Okay, so we have a line that a graph approaches but never touches. The reason why I'm talking about that is I want you to look at those two graphs that I made. And I told you, kind of described to you what that line was. Can somebody point it out for us? Where is the line on these two graphs that the curve approaches, but it never touches, it never crosses it? What's that? This one does too. Okay, they both have one. Where is it though? The x-axis. We would consider, I'm going to highlight it, I know it's blue on blue, we would consider that an asymptote in exponential curves. So it's never going to cross that. And you can think of it as the x-axis or y equals 0. Okay. So let's practice writing and doing a little graphing of some of these things. I asked you to have a calculator because when you start multiplying over and over by a number, sometimes the numbers get really small or really big. And so you might have some really large numbers or some small decimals. So let's take a look at this. First example, Mrs. McDonald's AP Stat students currently study for an average of 6 hours per week. I'm going to point out to you that I put that right there. That right now is the initial value of studying, okay? After spring break, they will be reviewing to take the AP statistics test. They will have 5 weeks to study and plan to double the amount they study every week. That's a very ambitious goal. What's double mean? Multiply by 2. Are you ready? Let's fill in the table. So right now, they're studying 6 hours. Would you multiply that by 2? What do you get? Whoa, already after week 1, I guess that's not so bad because it's for the whole week. At week 2, where would they be? 24. 12 times 2 is 24. At week 3, 48. Double this again. Week 4 times 2 is 96. And then week 5, 192. Okay, you're going to see there's a question that I ask about that in a second. Exponential growth grows really, really quickly. Like at first, not maybe so much, but then it does grow quite quickly. So let's write our equation. Let's remember up here that A is the y-intercept or initial value in our equation. We have y equals A times B to the x. What is A in this problem? 6. Very nice. And then the B value is what we're multiplying by. And you guys were doing this. What were you multiplying by? 2. So 6 times 2, and then we put the x up there. Because this just tells you how many times you multiplied. Here you multiplied once. Here you multiplied twice, right? 6 times 2 times 2. Here you multiplied 3 times, and so on. Okay, so the x, make sure you do that. Put the x in the exponent. Okay, Addison, what is the likelihood of this happening? You said?
None.
Not likely towards the end of that chart, okay? In fact, hold on. Birdie, you got a calculator. What's 24 times 7?
Yeah, I did it. It's 162.
Okay, so literally you're sleeping only a total of like 30 hours the week. But yeah, not feasible. All right. Let's pick these ones out. Let's do it with a graph. So very first, what would you please circle on this equation where it crosses the y-axis? The y-axis, yep. In the equation, y equals a times b to the x, because I have to figure out the a and the b. What did you just find? A, okay. Now, this one's a little bit trickier, but I think you can figure it out. You might have to look at some points prior, okay? First of all, it's going down. So this is going to be a number between 0 and 1. It was 20, and then it went to 10, and then it goes to 5. If you had to make a guess, what do you think that is? 2.5 probably, and maybe this is 1.25. I'm making the guesses here, but what are these? These are getting half as big, agreed? So you're multiplying by a half, or you could write it as 0.5. Make sure that's a 0.5 or 1/2. That's it. That's making the equation. You just got to find the a and the b. All right, next one. Would you circle a, please? Okay. What's a? Start your equation then. Y equals 4 times, okay. The next point I give you is 1/8. Well, is the y, if I went over 1, and what is the y value not added? What is the y value multiplied by? 4 times 2 is 8. So 4 times 2 to the x. If you went backwards 1, you could also see before that it was a 2, and isn't 2 times 2 4? Okay. Okay, good question. If you want to write it like this, that's fine. Where you want to be careful, Birdie, is that if you write a fraction, like let's say I had written it as a fraction, you need to have that whole exponent around it because you have to raise it to that fraction. So if you're going to write it as a fraction, use a parentheses, and so I just often use a parentheses. That way I don't have to think hard about that. All right. Oh, poop! We didn't graph this one, did we? It is. Let's graph some of these other ones on the back. Alrighty. So, when I am graphing this, if you want to make a table, you can, or you could just kind of have your calculator handy. Let's start at 0. What is the y-intercept? It is 1.5. The initial value is 1.5. Would you go ahead and put that on the y-axis, please? Now, do you see the scale is going up by 2? So just be real careful. So 1 would be like right here. 1.5 would be like halfway in between. Okay. Going forward, we're going to multiply by 2. What's 1.5 times 2?
3.
So I go to 1, 3. I'm going to leave some room here, but we said zero, I'm gonna go backwards in a sec, but 0, 1.5, when I put 1 time in, it came to 3. Would you plot 1, 3? Multiply by 2 again. What would I be at now? Can you type it in your calculator? Sure, but can you just do it in your head? If you multiplied by 3 by 2, what would you get? 6. Multiply 6 by 2. 12. And you could keep going, hopefully. What if I went backwards? Can you figure out what was multiplied by 2 to give you 1.5? If I went backwards, I'd have to figure out what was multiplied by 2 to give me 1.5. So go half of it, 0.75. Now all of these things would also match if you typed them in your calculator, if you put those values in for x. I'm just asking you to think about it. So -1 would go through 0.75, it would be down here. Would you draw a nice smooth curve through those points? And you want to be careful that it does not cross the x-axis, so it should look like that. Okay, this one you definitely want your calculator out for. First of all, it's really big, the y-intercept. That's okay, put it on the axis anyways. Approximate 21,004. It's going to be pretty close to halfway between 20,000 and 22,000, right? Kate, would you get your calculators out, please? I already did 0. Let's do a couple points, okay? What are we multiplying by? 0.86. Okay. So if you wanted to see how you put this in your calculator, you do 21,004 times 0.86, and you'd raise it. If I wanted to do the -1, I'd raise it to the -1, and I'd get it's 24,423. Do I really have room to put that on there? No. But if I had some space up here, it would be somewhere up here. All right, let's raise it to the first. I wanted to find a point over here. Okay. Would you raise it to the first? We already did the 0. I get 18,063. Would you plot 1 and 18,063 would be a little less than halfway between 18,000 and 20,000. All right, would you raise it to the second, please, now that I showed you how to do that? It's good for them, though, because they have to use their calculator. Yeah, you have to use your calculator. It's okay. Can I get somebody to raise it to the second? What'd you get? Mm-hmm. Yep, it's not nice. 15,534. Were you a little nervous because it wasn't nice?
Well, yeah, I just didn't know that would be like the raising, but
You know now.
yeah.
Okay, let's plot that a little bit more than halfway. Let's do to the third. Okay, now, here's the thing with exponential growth or decay. This is decaying, right? It's going down. Can you tell yet that it's going to curve? Not quite, but you got to know that it's going to. I mean, you're multiplying by 0.86. That's not all that much less than 1. So we're going to still, when we graph this, make sure we understand it is going to be a curve. So make some curve to those points. And kind of just make sure as I'm going off to the right that curve is going to level off somewhat. Okay, next. Here's how we decide if numbers are exponential. What we're going to do is remember how there has to be a multiplier. So if I wanted to go backwards, what's the reverse of multiplication? Oh, phew. You're making me nervous there a second. Okay, division. All right. What we're going to do to check is we're going to divide these values and we're going to see if they have the same ratio. And if they do, then they are exponential. 32 divided by 16. Do that for me, please. It's 2. All right. 16 divided by 8. 2. Ooh. 8 divided by 4. Cool. Are they all 2 when you divide them? Yes. Okay. Well, that's my justification. Where is the initial value when x is 0? Would you circle it in the table? Okay. So my equation is y equals 4 times, and you found the multiplier because you found what they were being multiplied by. 4 times 2 to the x. Okay. Let's try another one. We'll do this one. Would you do 19.8 divided by 8.8? Ish, this isn't nice. 19.8, and we're going to divide it by the previous one, 8.8. I got 2.25. Okay, let's do backwards again. Let's do 8.8 divided by 2.2. Uh-oh. Did you get 2.25? No, I got 4. Do I need to keep going? No. Okay, does that make sense? Shoosh. Long today. Let's take off